So nilikuwa nasema unapata kuna a lot of people wenye hawajui how to go about implementing a system na venye kuidesign with regards to venye project nafaa kuenda. Unapata tu mtu anapata project, then next thing ashaanza kujaribu kuandika code without even a plan on how to go about it, then anakuja na kama hapa mbele ukifaa kuwa na anajua ni nini. So tunataka Brad sasa ndio anatupeleka through your session. Ni Brad. Brad. Si unmute tuongee.
So, nilikuwa na shida na microphone but nisha resolve. So by the way, how are you guys?
Tuko fiti.
Fiti?
Labda
Sawa. Hiyo ni vizuri kama mko fiti. So leo tulikuwa tu tunataka kufanya an intro kuhusu water systems, system analysis and design, na tujaribu kutumia project yenu ambao mmepewa recently, watu wengi wanafanya, inaitwa printf. I mean not printf, simple shell. Tujaribu kuona kama tunaweza tukapata some basic designs na analysis kutoka kwa the requirements ambazo ALX walitupa. Tuende na hiyo process hadi venye tunaweza tukafika a point ambao unaona kabisa everything is clear. You can now even write pseudocode and start implementing the system. So that's like our main goal tunataka kufanya. Tukipata another time tunaweza tukajaribu pia with a different system. So I guess leo mimi na Kendi. So mimi na Kendi will be trying to take you through this session. Tujaribu tu kuonyesha a lot of the things that we have been gathering, doing research about, and pia zinatumika kwa industry, at least to build process ya venye mtu anaweza akaenda from thinking of a concept, writing down the requirements, hadi kuja ku execute a system. So I guess acha nimtransfer hiyo control Kendi, aanze tu na introduction like what is a system, atuonyeshe hizo vitu tu, atupitishe tu brush ya the software development cycle kabla sijafika kwenye stuff za kuchora hizo diagrams, ili ujue like in which part are you supposed to think about starting to draw diagrams or write things zianze kukaa clear. And it can work in a lot of systems hadi ambazo mtataka kufanya kama your final projects za ALX, hadi ukitaka kutengeneza any company of any magnitude, most of the diagrams that zitakuwa hapa they'll be of use. So Kendi, I think you'll get it from here now. Utachukua tu walk through what some basics to the system ili wa catch up.
Okay. Hi guys, mnanisikia?
Yup.
Okay.
Loud and clear.
Okay, sawa. Let me try and share the screen so that you can be able to see what I'm talking about. Give me a minute. Okay, sorry guys, it'll take time. So let's do this as we wait for that. Maybe I can ask you guys some questions and then we can make it an interactive session. Maybe someone can tell us what a system is. There are no wrong answers. Anybody? What is a system, guys? What do you think a system is?
Deep state.
No, in the context of software engineering. Am I
Or
in the
not in the context of a deep state.
no.
Come over to here.
Uh-huh. Anybody? What is a system, guys?
Can I answer?
Yes, please go ahead.
Uh, Let me try. A system is a combination of different components that work together to do a task, if I can put it that way.
Okay, so that's actually correct. A system is a bigger picture. So that basically means everything you see from the hardware to the software, the whole thing is a system. But in this context, it is a set of interconnected software components that work together to perform a specific function. Sindio? So that is basically a system. Um, I think this is screen it up. Let me see. Let's see. Can you guys see my screen? Can you see my screen, guys?
So they load.
Oh, okay. So
Tunaona.
naiona sawa. Okay, sawa. Okay. Yeah, so we're talking about a system, and tumesema in the context of software development, a system refers to a set of interconnected software components that work together to perform a specific function. So this includes everything from a simple web application to the complex operating system. All that is part of the system. Now, when it comes to coming up with a system, you realize that in most cases with ALX projects, we go straight to maybe read the requirements and then unaanza code. But in the real life situation, it doesn't work like that. There's a process you go through because if a client approaches you, we want you to create maybe a certain web application for us. You won't just go ahead once a code. So there's something that is called software development life cycle. It is a life cycle because it is a continuous process. Yani ikiisha inaanza tena. So, so we say it is a process that produces software with the highest quality and lowest cost in the shortest time possible. Produces a well-structured flow of phases that help an organization to quickly produce high-quality software, which is well-tested and ready for production use. So there are some steps in the software development life cycle, and there are also models in the software development cycle, which we'll look at maybe later. So let's go straight in the steps. So we have the requirements determinants. So this is basically when maybe a client approaches you to create a system or to develop a system for you, for them. First, you get the requirements. See the determinants of the requirement. So in this stage, it involves determining the application with the highest priority among applications applied by an organization. So a client will come with so much information, but now you have to prioritize on what is needed for the system that they want you to do for them. Is that clear, guys? Sitaki kuongea peke yangu. Let's make it interactive. If you have anything to add, stop me. Nanisikia? Wambua?
Yes,
Wambua?
niambie Kendi nakusikia.
Yeah, so class, hii ni interactive session.
Yes,
So nataka kusikia kelele. Okay, sawa. Aya, so let's go. Let's continue so that we don't lose focus. So this is the first step. Sawa. It goes hand in hand with the second step, which is the requirement specification. This is understanding the existing system application and where a system is required. So here, or of course, if you're getting the requirements, you're meeting with the client, the person who is in charge of that whole development thing is meeting with the person requesting the system to be done for them. So you're meeting with them, however, virtual or in person. So you're getting these requirements are coming from the client. You're not the one making them. So they have to be the ones telling you all this. So let's see. So you list all the requirements of the system. Okay. The next one is feasibility analysis. So we are going step by step because tumesema it's a cycle. Sindo, it's a life cycle. So you start from the first step, then you move to the second step. Now we're in the third step, which is the feasibility analysis. A feasibility study is a test of a system proposal according to its workability. Sawa, guys.
Yup.
Yeah. So yeah. And then after the feasibility study, which is analyzing the workability of the system with the requirements and the criteria, we now move to the specification. This is the final specification, which states what the system is supposed to achieve. Sawa. Are we together?
Yup.
Yes, we are. Just to add on something, I don't know kama kuna watu wameshaonaga maybe wamejaribu tu kufanya a gig outside, wakaona venye mtu anaweza akampa a really weird project requirement, alafu maybe hana hizo resources za kuketa, maybe hana hizo servers za kuhandle those types of things that anataka. Sometimes kuna a lot of noise in what the client wants or what the system is required to do, that hadi mfikie hiyo point ambayo mmeagree inachukua time. So hizo process hapo juu, hizo wakati mnajaribu kuangalia what is feasible in the time period ambayo umepewa, ama unataka hiyo system. So hiyo tu ni process yote ya kufilter a lot of noise mpaka mfike na the final specification, which is something that is sort of implementable. Ukija ukikaa hivi unaona kabisa this is something that I can do, alafu unaanza tu kuendelea na process za implementation, but acha endelee.
Okay, sawa. So tuko kwa final specifications. So this hapa ndo sasa mna state what the system is supposed to achieve, and then during hapa pia this is where you write the SRS. If I'm not wrong, I think the SRS stands for Software Requirement Specification. So it's actually a legal document that can be held in contempt if you go against it, because it has all the requirements of your system, the agreements of how long maybe the project should take, all those things that are. Bradley, am I saying stories are Java? Kama niko sawa.
Niko tu sawa.
Uko sawa?
Yeah. So that is the actually this from my experience. This is a very important document so that it because it's supposed to protect you and also protect the client in case anything happens because it's on all the specifications. So later on the client can't come and kama alikwambia you create maybe a critical system of a hospital after umemaliza it's a lot of work, right, and a dedication. And then after you're done, so they can't come and say, no, we didn't tell you to create this system, we told you to create a matatu booking system. So this is a very important document because it protects you and also the client. Okay, then after that, now, so now you go to the hardware study. So umeshamalizana na client, amekupewa the requirements, umeelewa what is expected of you and what meets the requirements amekupatia. Now you're in the hardware study. You determine the hardware and the software required to execute the application amekwambia ufanyie because different system will probably require different kinds of hardware and software. So you need to determine that before you proceed. And then you determine also the response time, the volume of data to be produced, frequency of reports, and pick the hardware. And then now we move to the system design. So kwa system design sasa, kuna logical design of the system, identifying objects, database design, program specification, implementation, na test plan. He Bradley ataongea about it in broad. But for now, just know that the process inafuata the system design, and then now you start the implementation of the design. So yeah, this stage includes writing programs or coding. This is where most of maybe the ALX projects will begin. Yeah. So as you can see, this is the 7th step. So tutakuwa tumeruka a lot of steps, then you start here, but it's understandable because it's for education purposes. This stage includes writing programs or coding, creating database, document system, train users, trial run of the system, hivyo. So basically implementation of whatever umeweka kwa design. The next one is evaluation. So once you've implemented, now you need to evaluate the system. You check whether the system meets the specific requirements, and then you list the dissatisfactions, and then you find a way to mitigate them. And then finally, you suggest if there has to be any improvements to the system. Does that make sense?
Yeah, ina make sense. So wengine tu tunaanza steps hapo step 7.
So ndio nilikuwa nasema a lot of times kwa hizi projects we start from step 7, so we never get to know what happens for system design. So this part Bradley is going to explain what happens in system design from the first thing you do kwa system design to the last one, because hapa ndio kazi iko actually, because without the design what are you coding? You understand? So you need to come up with a design, then that design is now what is going to guide you to know. It's like the design, okay, for an example, when we talk about identifying maybe the database design, kuna so many database designs. So huwezi amka tu hivi uamue, sawa, wacha niende na you have to decide which one is going to vibe with the requirements za your specific system. Is the SC Thursday. Okay, sawa, tuendelee. Alright, so tumefika hapo, tuko kwa evaluation, tukasema so you find out from the user whether the system meets specified requirements. Kumbuka, hii system si yako. So ukiimplement anything, una involve the user. Si ndio? una create from the perspective of a user. Lazima ikuwe able to meet requirements za user mwenye anaenda kuitumia. You understand, guys?
Yeah.
Yeah. So then you list the areas of dissatisfaction, and you find reasons for them. Because we all know when tunajua venye hizi code zinatufanyanga maneno huko nyuma, so you have to keep checking whether everything is okay, and then you suggest if there are any improvements that can be done to the system. Yeah. And then you move now to the modification stage. This is where now you fix all the errors that you may find for evaluation, and then you add or delete features as required, and then you tune the system, and then you now implement the monitoring system and assess the performance of the system. So that's about it. There's 9 steps. I think these are the most important steps. It can vary with different organizations, but this is basically what it looks like, the SDLC.
Incredible.
You guys
Okay.
get that? What have you learned?
Mi nimelearn tu nisikuwe naanza step 7.
Hiyo pia ni kitu poa kulearn. So yeah, basically cram easy steps. Like I'm sure put in the real life situation of how you'll create a system for a client, makes sense. So it's nothing to cram. It will just come. Itakuwa tu in a flow, like with time. I guess maybe if it's the first time, utakuwa like a bit confused, but it's very basic steps. With time, learn. But just know these are the steps that will be required to go through.
Na mtu akicreate system yake
Hata
ina
ukikuwa freelance.
involve client.
Okay, guys. I think mimi sasa I'm going to take you through hiyo sasa phase ya design system. Like you have all the requirements. Nita deal na diagrams ambazo zinaweza kutusaidia kuachieve a good design. Na since a lot of you guys mnafanya story ya simple shell, lika tukaona pia like after this design phase, I think most of you mtaelewa a lot about the project through the different diagrams that we'll be doing. I want it to be a sort of interactive session, so I'll be going through those 7 steps, like a context diagram, ama zinaitwaga level 0 DFDs, and then tutaenda through actually sort of like 1, 2, 3, 3 to 4 of these depending on the time that we'll have. And then we'll think of the other week what to go about, but it just builds on the idea that these are the things that you would actually need to develop a professional system in a setting of a relatively big company kama unataka kuanzisha, na sio hobby project yako tu unaamua kufanya, where you have a collaboration team. These diagrams ni diagrams ambazo ziko widely known na kila dev ambaye ataingia kwenye kampani yako akicheki hivi ataelewa what's going on bila like kumwelezea kumget to speed sana, because it's like a convention tayari imeshasitiwa. So I think I'll start sharing the screen, but please guys, naombeni tu tufanye hii kitu collaboratively, tujaribu kufigure out the simple shell program, how it works. Sawa, according to hizo requirements ambazo mlipewa na ALX, we just want to use those requirements ndo tuzifanye sasa. We take those requirements tunazifanya kama our system specification requirements that we are supposed to develop. and make it more interactive. So points ambazo nitakuwa nimeuma nje, you guys can correct, we can learn from each other, we can have better understanding of it. Na kama msi alikuwa haja understand kuhusu hii project, I think ataelewa more kuhusu the system. Okay, so I guess nimesha share screen yangu. Nitatumia hii tool inaitwa I think draw.io. So the first system that I would like to talk about ni inaitwa DFD. I think niko na hiyo doc ambayo ameshare. Okay, I think this is what I'll be speaking about. Nitaanza na context diagram, which is a level 0. DFDs inaitwa data flow diagrams in long form. So they just show how the data flows in your application. You already have, or in your system, you already have the requirements, but how does data flow inatoka from this process to another process to another process, just to make it more clear to you who is developing the system. So let's say sasa context diagram inakuwaga ni the easiest one because inakaaga on, it's the first like really general diagram ambayo iko. So it has two things only. It has the system here. So in our case, like let's say we are developing a simple shell system. It has this system represented as an ellipse or a round, whatever you can, inakuwaga na hiyo shape. Alafu it has the entity that is connected to the system. So in our case, I believe that the entity that is connected to our system is only a user. A user is the one that interacts with a simple shell. Sindio?
Yep.
Yeah, so, and when we call this level 0 DFDs, we mean that there is data flowing through this system. So what is the data that can be flowing from a user to interact with our system? So in our case, maybe something like a command, right? Our user types in a command, then the command is inserted into our system. That is all we care about right now. That's why it's called level 0. It has no any complexity. It just shows the overall systems and the players who are interacting with that system. So the command is the input, but what does the system like give out as its output? When you type in a command, you expect an output, right? Yeah, so let's say like after doing whatever the system does, we expect an output as data from the simple shell system. And then this becomes our level 0 diagram. So this becomes our level 0 DFD or context diagram. In an ideal system, let's say like you are developing something like M-Pesa, kutakuwa na a lot of people wako hapa. Kutakuwa kuna agents ambao wanafanya interaction na M-Pesa system. Kutakuwa na watu ambao wana deal na APIs, like let's say developers ambao wana interact na the M-Pesa system. Kutakuwa na institutions ambazo zina rely on the M-Pesa system. So kutakuwa kuna a lot of entities. Let this not fool you that it's a simple system. I mean, it's a simple diagram. It's just that kwa case yetu, juu tumeamua to build a simple shell, the only one entity is the one that will be interacting with the system. So like tukitoka hapa, I want to touch upon another level of the system. So ukishatoka hii level 0 of the system, you can go to level 1 of the system, where in this level 1, we'll be talking about this simple shell in deep, like what is happening inside the simple shell. So inside the simple shell, like we must have a user, right? That is one thing we are guaranteed of. So Control Z. Okay, let me just take one. Let's say we have a user who is interacting with our system, okay? But now, instead of just generalizing this simple shell system, we talk about the things that are supposed to be there as a process. You see, we never discussed about the percentage when we are defining this system. But sasa hii tutaanza kudeal na processes. Where is the container page? Let me just search for process. Okay, so let's say something like this. So a process, acha niibe template. Control copy. Okay, let's say this is our process. Sorry. We give it a number, like this is the number of the process, then we give it what the process is supposed to do. So in a really high level bado, hatujaingia ndani sana, it is supposed to handle command input, right? And after handling command input, there is another process which is supposed to do something like to pass the command. Uh, uh, so it does the command parsing, right? And then after the command is passed, we are supposed to have like another process. Let me give it a different number. Each process has a different number for another reason. I'll show you just in a moment. Baada ya tuseme command kwenye your simple shell, when you're writing up, when you're typing a program, and according to the requirements ambazo tulipewa na ALX, after the command is passed, it must be executed, right? So this system, this subsystem or this process will deal with the command execution, right? Execution. And we'll give it a different, yeah, we'll give it. Na ya mwisho kabisa, Control D. Okay. Let's say the last step will deal with the display, right? So the command output. And also in our system, we can anticipate, we're still dealing with the simple shell system. We can anticipate that we'll have a form of storage, right? Your storage sio lazima iwe ya database, inaweza ikawa hata buffer. A buffer is a form of storage. Yeah. So we can use a type of storage. Let me get just one. Maybe, control code. Just get a buffer. Control V. Okay. Control copy and paste. Okay. So ukisoma vizuri hiyo requirements ambazo mmepewa na ALX ya kuunda the simple shell, they kind of want you to store the input command in a buffer so that you can pass it, alafu ukishaipass uipitishe kwa a certain system call ambayo inaitwa exve who create like a child process. I think hizi hapa, if you went through the materials that were given, if you read through this whole document na the resources that mmepewa, you realize that you can just go and get a like a high overview of this project, ukarudi tu kwa hiyo project ambao mmefanya, kama umeshafanya ama ndo unataka kufanya or you're doing it right now, ukaelewa tu like this is what they wanted us to do on a still higher level, like an abstract level. So the user should type a command to a process that listens for command input. So this process inakuaga is, I believe it's interactive, na unatumiaga a syscall inaitwa isAti. So unakuaga una listen kama hiyo system, hiyo context ya simple shell inaraniwa kama an interactive shell. And if it's interactive, unachukua what the command is, unachukua the command that is passed in the command input, unaistore kwanza kwa a temporary buffer, alafu unatengeneza a parser ya kupass your command, to make sure that inside a parser we are trying to make sure that the command is valid, it's a valid command, and it follows all the guidelines of running that thing. Let's say like CD, you can't pass CD without without arguments. Like you must pass CD with where you want to go to, because it's a change directory. Where do you want to go to the change directory? So like this process, command passing deals with something like that. In a handle the passing, if there is any error, it immediately skips the execution and it goes to the output to print out the error. I don't know if I'm making myself clear, man, ninaongea mwenyewe. Guys, are we together?
Yeah, tuko pamoja, uongee Jaba.
Sawa. Okay, let's say sa unaona kwenye hizi arrows we try to pass in the types of data that is anticipated to go through these processes, because this is a process and this is a process and this is a process and this is a process, and we have given them numbers because we're going to expound on them to dig deep. What happens in the command input? What happens in the command passing? What happens in the command execution and command output? And I think by the end of kufanya this diagram tukaingia another level and another level, most of you mtaweza kuelewa a lot about what the project really wanted you to do, hadi ikifika point unaweza ukastopia tu kwenye hizi DFDs ukaamua ukawa tempted kuanza kucode. Let's say that it is saving the command, right, into an input buffer, and then that input buffer is then passing the command, okay? So it is passing in the command to the parser, and then the parser, what will the parser pass? The parser will pass a valid, let's call this a valid command to the command executioning process, and then this process, once it finishes, it will pass the output output of the process. The process has terminated. This is the output that you get. Maybe CD, it shows you the CD, what you wanted to. I mean, let's say it's ls. You are trying to see the contents of a directory. What is required to be printed out will be handled by the command output process. So this is how I've like simplified it so that it kind of makes sense. Now let's start thinking of each system individually. Like you see this is level 1 diagram. It's still a high level interpretation of our system. But let's go one level deeper, alafu uone venye vitu vinaanza kuwa interesting. Let's go in level 2. Level 2, yeah, hii diagram. Now here we're going to start with one process after another. So we are going to start with the command input process. But one good thing about it sasa hivi is we won't mention the process again. Wait a minute. Just give me a minute, guys. You told me. Yeah. Okay. Acha tu niichukue hizi hapa. So let's say we are looking at the user who is interacting with the command input. So what do you think can be inside the command input? First of all, we must have a process that listens, right? It listens for the inputs from the keyboard, right? Guys,
tunasikia tuna process.
tuko chojo. Haikufeel kama lake manzi.
Lakini wewe ni lake.
Azi.
Tutakuwa
Okay.
kazi kwa lake ALX.
So, ukiwa una expound sasa on a system, zile namba ndo zinakuwa important. Like sasa hapa, instead of writing process 1, we'll write 1.1. So anyone that is looking at this diagram, anajua we are looking at this process, but tumeamua kuingia ndani ya hiyo process. So we said, what will this sub-process do is it will listen for command input, right? Let's from keyboard. So this is what our process will do. And then what next process can we have, guys? Guys, jamani, hata mtu mmoja jamani. Okay. Let's say that after listening for the command input, what will you do next? We'll store the command in a
Catch.
No, in a buffer.
Oh, buffer. Oh, shit.
Ile una define tu ile sijui ni argument vector unaichukua, that's a buffer. And then the last process that people really don't talk about but is essential hapa is what happens when someone close the terminal.
End of file. End of UF.
Yeah, so that's also a process, right? So that process can be like exiting. It's like to exit
The process.
listening the input. Whenever you're listening to the input, you are running the file, the shell in an interactive mode, right? Unakuwa unairun tu kwenye a sort of interactive mode where you wait, mtu akitype, let me take an example, nifungue hapa Ubuntu. Like you see this program, this shell is always listening for what I type. If I type ls, inaichukua, inaiprocess, inaniletea output. But if maybe I don't know kama kuna exit, umeona nikitype exit, it exits the listening of the input na inajifunga. So that's a really important process pia. And we can like show these processes venye zinavyokuwa. To speed up time, sahii sitaonyesha the types of data that ziko hapa, but jua tu user akiwa na nani here, it's something like a command that is passed in, and listening to the here hapa it's a command. A command is the data that is passed to this process, and then the stored buffer, I mean the stored command in a buffer, we can create a storage unit kama hii. Now we write our command buffer. Wait. We can write that this, when it stores, it reaches a point where it stores, right? So this is stored as a variable. Haihitaji kuwa kitu complex. It's just storing a command kwenye an input buffer so that hata akiwa na type vitu vingapi uweze kuvicapture. Sasa tukimaliza hapo, tukikuja kwenye stuff ya command passing, we get to understand a lot of things. Now it is really important to see that ili upass what the shell is supposed to do, you need to get it from an input buffer. Let's say you defined maybe a global environment variable ambao utakuwa unachukua all the commands unazisave kwenye environment variable kama a pointer, a double pointer, so that you can store an array of commands, alafu you are getting those commands sasa kwenye system ambayo ina pass. So let's see sasa level 2, where our initial entity that is giving us data will now be the command input buffer. And then it will be feeding us input to our process. Oh, wait. Okay. Control Z. Control Z. So let's think of now kitu kama kupass. What happens in passing? Ukisoma hizo requirements za stuff za requirements za ALX, guys, na hizi command zote ambazo mmepewa hapa, because unatakiwa ukisoma hizi zote kabla uingie fork, you are supposed to pass. I think we should even come to like an example about this. Hii kitu ambacho alikuwa anaongelea hapa, bash, one of the resources, kuna ile resource alikuwa anasema everything you need to know about a shell. Okay, mtaangalia, but kuna hiyo stage ambayo unatakiwa uangalie if everything that is inside if everything that is passed in the command makes sense kabla hata hujaenda mbali. So that's like parsing. You're going through each and every command that is passed on the keyboard, and then you're trying to see if it is equal in exist, is it a valid program, and things like that. Sasa, the first step that we can say can be getting the commands, right, from the command input buffer. Okay, that's like one really important process. And then shamaliza hapo, go like doing 2.2. You can do like lexical analysis. Sio maneno makubwa, it just means tokenization. Kwenye hii step unajua utakuwa umepitishiwa a lot of commands, sijui ls, la, hizo vitu vyote zimechukuliwa, zote zimekuwa captured kama string. So lazima ugeuze each and every command pale, each and every word into a token. Alafu ukishazigeuza kama token, unaziekaga kwenye an executing vector, ndio zinaweza kuexecutiwa command after command. Like let's say let's just go to Ubuntu. Like when I type ls la, it breaks down the ls into its own command, this into its own command, and then L into its own command, and A into its own command. And why did I say ls inakuwa kama command moja? Because ls is actually a file executable within the system that it identifies. And these are just additional parameters that are there. So lazima iwekwe kwenye kitu kama zigawanywe zote into tokens so that they can be passed to the command execution process. So kazi yake itazigawanya into everything that is required. Yeah, Control Z. Oh Lord. Okay. And then after that, we can do something like a syntax analysis. We try to see the command structure and the correct usage of arguments. Ikishazi break down sasa into let me first write that process, alafu I try to show you what it means. .3. So we do something like a syntax analysis, where we'll talk about kitu kama the command structure. The command structure, correctness, usage of args. Kuna some programs kama mmeshaangalia, they have a way that they accept additional arguments after running the program. Sa let's say kitu kama GCC, unachukuaga GCC, unapassing sijui output, unapassing file name na hadi unavyotaka kila kitu kikae. This is a file, sawa? It's a file and it's found somewhere in the environment variable, and we'll talk about it a bit. But in this step, we just want to know if this is allowed, passing in extra arguments what to the command, to the base command that is there, kama GCC. So we're just looking at the command structure, correctness, and usage of the arguments. And then after this process, we can do something like wait a minute. Uh, 2.4, we can talk about error handling. Error handling. Let's say ukaja ukaona that your stuff, it doesn't make sense. Like nimepass ls, it doesn't look, ama in a weird command nimetype like a long string that doesn't make sense and is not, doesn't look like a valid command, right? In your level define your execution, you can automatically go to the error handling and throw off an error instead of kujaribu kuingiza that command into an execution vector. And then after that, if let's say the command is okay, it doesn't have any problems, we can talk about preparation. In this step, 2.5, we can talk about command execution preparation. Now we are trying to like make the command iwe prepared for execution, because I think mmeambiwa mna deal na kitu inaitwa exve, mlipewa hapa muipitie. This one, it requires a specific format ili ipass in command. So that step of preparing so that hiyo command iweze kuwa passed on will be dealt in something like the parsers. Ina pass through the already correct command, inaangalia kama they are good, they are well tokenized, alafu inaziweka kwenye what is it called? You can even use like pointers kutengeneza an array ambayo itakuwa na all the commands that are supposed. Na kama utaamua utengeneze a sophisticated data structure, wengine walikuwa wanatengeneza hadi trees. It's just you deal with how complex you want your system to be, and then you can implement it in anyhow that you see fit. It doesn't like limit you kuanza iti kutumia this data structure over this. You just use your creativity. And then sasa tukija kwenye stuff ya, tukija kwenye process ya command execution is, first of all, we must see what is the input source. What is the input source of our third process? Our third process that we want to expound on, the command execution. So let's say that Control D, 3.1. Now we get or retrieve the command from where it was stored, and then after retrieving the command, we can like do something like try to search for its context. I think kuna stuff hapa waliongelea kuhusu the environment variables setting. So in order for you to run any program, lazima we search kama in exist into these folders ambazo zinakuwaga set in the environment variables. Just give me a moment guys, just a bit. Kunakuwaga na hii folder inaitwa bin. So yes, kiangalia ina all the commands that you guys run, gpg, git, pkill, pro, ps, pslog, psql, all the commands that you write, pwd. So these are actual files which are executables that are inside this bin. So like tukirudi nyuma alafu tukaangalia our environment variables, we'll see that they are there. Na kuna context ya hiyo ya shell where it looks for the bin bash and all these other environments. So when a program is starting to run, it always goes to the environment variables, alafu inakuja inaangalia if the program that I'm trying to look, is it in bin bash? Is it in Ubuntu? Is it in desktop? Is it in... It goes through all these chains trying to find the required directory that it will find your executable ya kurun. And if it gets it, inaitumia hiyo context kurun hiyo program yako. That's why unahitaji uwe na vitu tuseme, you need things like environment variables. So you can do something like search for environment variable context of execution. Alafu in case amedefine kwa kutumia a set env, anataka ku add a different path where you can search for that executable, you can just do that. Kama kuna hiyo process ya ku set env, I think someone can just like do a set env of the variable that is required, and then akitoka hapo anaweza kutukana na process. I'm trying to speed it up guys. Akitoka hapo anaweza aka search for executable in that env variable, so that aweze kupata hiyo project, hiyo file ambayo inaitwa ls, hiyo executable inaitwa ls, aweze kuirun na those given commands. Alafu akishaweza kufanya kitu kama hicho, anatakiwa awe na uwezo wa kucreate, kabla ya kucreate, let's say control D, control Z. Let's say huyu mtu anatakiwa awe na uwezo wa kuhandle error. Ana handle error in the sense that amekuja akatafuta that program, it's not existing in all the environments that are there. So that program, that command cannot be run, right? So your command ikishindwa kuraniwa, you don't want to even go to forking a process or doing anything complex. You just want to throw an error. So this will handle the error. And then if this is successful, we want to do something like, create a new child process, child process. And then after creating a new child process, we can hand over the execution of that process to the child process. The child process and then ndio hii process sasa una fork. You fork only if the command exist. Hapa umesha fork, hapa una pass in sasa, unatumia exve ku create like ku run your command sasa. And then after doing something like this, you can try to listen to what the child process does, right? Listen to the output of the child process. Because a child process, when it terminates, it returns an output, it returns something. Kama imeshindwa kucreatiwa, it returns -1. And then after that, I think sisi tutakuwa tumesha handle the execution part. We'll go to the last part, that is displaying the output, which in our case that wacha tu nichukue. Guys, mtanisamea tunakimbiza ili muweze ku get a bit of something. Hata inatakiwe 4. Sijazi change hizo numbers, but I think you get the gist kidogo. So the first thing is it captures the output. Let's say after listening to the process, we created a buffer. Control D. Let's go here. We captured the output and then we stored it into a buffer. So there is a command output buffer. That had the output result baada ya listen to the output of the child process. Let's say hapa baada ya listen to the child output process, we save the results to the command output buffer. Now the command output buffer is it's supposed to be the other way. The command output buffer is supposed to feed in data. So there is a function that captures the output, and then after capturing the output, sasa, this is the final part that you want to be displayed. Control copy. You want to read the output. And then after that, after reading the output, you want to format the output, because everyone knows that the errors are not the same. They are somehow formatted. Some people wanna add some sort of formatting tools about errors in red. That is done by the format output process. And the last thing is the display. Control D. The display output function. So ukiona venye tulichukua hizi process ambazo zilikuwa huku, this simple process tukai break down to the second level, we came to really understand the execution logic na how the data is passed on. Hadi tukitoka hii level, tunaweza tukaanza sasa hivi kuandika sort of pseudocode of what is expected to happen, ambayo inaweza ikatufanya hata tuandike code. So this is really helpful in a lot of systems. Maybe our system iko that of a good overuse case, but I just wanted to show you how you can break down these DFD diagrams into really low levels hadi uweze kuona that this is what I can get from this process, na naweza nika execute aje hadi inakaa kitu attainable kabisa. Then tukitoka hapa, There are other things that we'll talk about, I think, in the next session. But right now, I guess we have done a bit of explaining, and I think a lot of people like wanataka kuishia. And then we'll talk more about it. I guess we'll end the session leo. Sasa hivi. So guys, anyone who has like any question kwa nyie mliobaki, so that tusiwaache watu waliotaka kuishia waondoke, wawe nyuma. I mean, anyone who has like a question, who wants to talk about something, maybe haikuwa clear, we can go through it. Guys, mko hata on jamani, ama was I speaking to myself? Hello.
Kidogo. Yo Brad, niambie, niko hapa.
Nauliza kuna any question au kuna mtu amepotea along the way alitaka like nirudie sehemu juu naona kama nilikuwa
Labda waseme, mi sina anything ya kusema on my end other to than kuambia wewe na Kendi, asante sana for kutuletea session ya leo.
like at least imeeleweka kidogo
Kabisa manze, kuna vitu hapo sikukuwa najua kwa system design, saizi at least naweza nikazi implement kwa projects zenye ziko huku mbele.
Yeah, like kuna a lot of like diagrams, especially kitu kama DFDs tukishamaliza tuingie ERDs. Hizo diagram zote makes all the system requirements that for any given system seem like ziko implementable, hata kama hiyo system iwe complex aje. Unavyochora
lazima uko umezimplement hapo ndani.
Juu umeona saa ukitoka like kwenye hizi DFDs ambazo nilikuwa nachora, hata kama sijamaliza due to time given, nilikuwa tu ninazi highlight juu, but unaona kuanzia hapa you can kind of get a gist of how you can execute the code na how you can like package the code, because hapo unaona like listening for command input from the keyboard. So this is always an ongoing process. Unaweza kufanya kitu like a while loop, things like those.
And also to have like a clear structure ya kukusaidia kujua venye how to proceed with your code. Si kuingia tu kimalamala, shida inatokea hata ujui uanze kufanya nini hapa na pale, but at least ukiwa na structure unajua how to proceed. Kitu ikiharibika unajua uta fall back wapi ndo urudi tena uendelee.
Like unarudi kwa diagram zako, unaangalia where the logic is faulty kabla ya kuanza tu kuimplement bila kuwa na a clear structure of what you're doing.
Sasa shukran manze. In case hakuna any further questions, wacha to end session ya leo, tutaweka link kwa group baadaye.
Okay, fiti. Okay, thank you guys for joining. Oh, would like to speak.
Sema.
Kijana.
Emmanuel.
Ndio.
Ati? Oi, Emmanuel, hatukusikii bro.
Nilikuwa nasema hiyo recording naweza ipata there's too much information hapa hivi hadi kidogo nimepotea tena.
Itawekwa kwa group, tutaipost kwa group, mtaipata hapo hivyo.
Poa. Bradley, hiyo na appreciate manze. Uko tu sawa.
Sawa.
Shukran.
Acha tu end call alafu tutaweka link kwa group.
Sawa.